Good afternoon. My name is Jaron Larson, and today I'm going to be showing you a brief overview of my research regarding neck cross-sectional area and the covariances of sex, BMI, and age. Primarily, the effect of neck research on crash dummies. Currently, we have a limited demographic availability in crash testing, limited to average males and small females. This is mainly attributed to the cost of research in the field of automotive crash and dummy development. Additionally, when it comes to the neck research specifically, it is an extremely difficult part of the body to research simply due to the lack of data. And the lack of this data comes from two primary sources. First of all, it's actually measurement inaccuracy and measurement labor. It takes a lot of time and expertise to measure the cross-sectional area of neck muscles. So as a result, oftentimes data sets are limited in size, which is an issue because a lot of data sets also have a skew towards a male bias. To set out our research objective, we want to prove that there is a difference in male to female neck cross-sectional area. More specifically, we want to prove that that's a variance between age and BMI. But we also want to do a technology assessment of using segmented muscles in order to do this research. We want to verify the quality of these segmentations, and then we also want to use cross-sectional area analysis from these segmentations to prove our hypothesis. So to jump into our methodology, we are using over 5,000 CT scans from University of Michigan Radiology, which we are feeding into our total segmentator AI program, which is able to generate these 3D neck muscle structures, which is the data set that we are able to plug into our proprietary program to quantify and interpret data, particularly the cross-sectional areas for statistical analysis. When we look at the quality of these AIs, it's actually very positive. The muscle groups we chose to evaluate, the levator scapula, proverbial, and sternocleidomastoid mastoid, all have nearly over 90% accuracy. And there's no obvious bias from age to BMI. And then this little graphic does show that process of what the computer sees, as well as what we looked at doing our manual segmentation. Now, as far as the quantification of cross-sectional area, we take the 3D volumes of muscles and we shrink them down to one dimensions, which gives us a nice center line. That's this red part on the screen. When we have this center line, we smooth it out to remove any sort of jagged variation. And then we're actually able to use this center line to cut a perpendicular tangent angle, which actually finds the cross-sectional area of that ring. And then we do that every single millimeter down the muscle. Compare all those values and pull out the largest slice, kind of like when you pick a big slice of pizza out of a pizza box and you're really hungry. We export that data from that cross-sectional area to a spreadsheet where we can do statistical analysis as well. Before we do statistical analysis, we do some validation of our data. The most effective method is actually to compare left and right muscles we found, where we do see a strong correlation between left muscle and right muscle sizes, but we do look for cases where there's over 100 millimeters of variation in neck muscle size. And if that's the case, we simply remove the subject from the database to avoid any potential data skewing, which means we removed a total of 35 subjects across all demographics. With our statistical testing, we were able to prove or reject our null hypothesis and prove our alternative, which does show that sex, BMI, and age are all independently statistically significant in neck cross-sectional area. And then we were able to do this with a 95% confidence interval because we have the largest population in research regarding neck cross-sectional areas, which is really cool. Some visual trends to look at as well as we do see a negative trend in age to cross-sectional area with positive trends in BMI and cross-sectional area. But then regardless of cross-sectional area, we can also see that generally speaking, males do have that larger cross-sectional area difference compared to females. Now, as far as future work goes, we want to improve our algorithm and our slicing and our AI to be more diverse and to look at more muscle groups rather than just these specific muscles in the neck. So that's going to take a little bit of retraining as well as some more fine tuning of our center line algorithms. But these can apply to many different research projects here at UMTRI, such as the Hermes model, which can obviously represent various demographics of data, as well as crash test simulation, where we can plug in this neck data to give us force vectors to actually see how the neck behaves. Yeah, this has been a pleasure. Thank you guys for watching my video, and I look forward to speaking and responding to questions. Thank you.